Welcome students. In today's video we're going to take a look at how to solve single-step algebra equations involving addition and subtraction. Before we get started, what does your computer do for lunch? Oh, it has a byte. Get it? Like, bytes are units of storage for computers, so like megabyte. No? Okay. Anyway. Alright, sorry, that one was lame. Looking at our steps for solving algebra equations. So anytime we're given an algebra equation, if we follow these steps, we can, go step by step and work towards our solution for solving it for what that variable represents. Okay, our first step. Whenever we're looking at an algebra equation, we always want to start on the side with the variable. So whichever side has the variable on it is the side that we want to start on. Now I know that when you get to later grades you'll see some with variables on both sides, but for ours we're typically just going to see them on one side. Okay, our second step. We're going to use inverse operations to what's called isolate the variable. And isolate the variable just means get the variable on its own. So that means make it into like x equals or y equals, right? That's what we mean when we say isolate the variable, is get the variable on its own. Whenever we're doing this using the inverse operations, we have to do the same thing on both sides of the equation. That's the only way that we can keep the equation balanced. If we do something on one side but not the other, now our equation becomes out of balance. And then finally we test our solution by substituting the value. So substituting the value back into the original equation. So whatever we find, like let's say it's x equals 3, we take 3 and we substitute it back into our original equation and test to see if it's correct. All right, now let's see this in action, okay? So when we look at our first example, it says 23 equals m plus 12. Well, I like to do the dotted line down the equal sign. That helps me to keep myself balanced, right? To understand what I'm doing on one side, I do on the other. Remember, our first step, we're always going to start on the side with the variable. So in this case, that's the right side because my variable is m. Okay, so now I'm going to do the inverse operation of whatever's happening on that side to get the variable on its own. And I can identify here, it's m plus 12, right? I'm adding 12. So the inverse of adding 12 would be subtracting 12. So 12 minus 12 is 0, which is going to get me back to just m on that side. But remember, step 3, do the same thing on both sides of the equation. I can't just subtract 12 from one side of the equation because it's going to make my equation unbalanced. So 12 minus 12 is 0. I end up with just m on this side of the equation. And then on the other side I have 23 minus 12, which gives me a difference of 11 as my final answer for m. Now, our last step, step 4, we're going to substitute 11 back into our original equation for m to test to make sure that it works. So my original equation was 23 equals m plus 12, right? But instead of m, now I'm going to write 11 because that's what I got as my solution. And I'm going to see if that is a true statement. 11 plus 12 is 23. And I see that 23 equals 23. So I am good. That is a true statement. 11 works as my value for m. All right, let's take a look at a couple more examples here because there's a couple more situations we're going to see. So our next example we see, it's the same situation-ish, but now we're going to have subtraction. Our steps are the same for this one. Right? I'm going to do the dotted line. I recommend doing this for the beginning. Once you get good at this, you don't have to continue, but it is definitely a helpful step. I'm going to start on the side with the variable, so in this case that is the left side of the equation here. And now it says I'm going to use inverse operations to isolate the variable. So what's happening here? It's n minus 15. I want to get rid of this minus 15, so the inverse of subtracting 15 is adding 15. Okay, remember, I need to do the same thing to both sides of the equation. So if I add 15 on the left side, I have to add 15 on the right side to stay balanced. Okay, so when I do this, negative 15 plus 15 is the same thing as saying 15 minus 15. It cancels out. All I'm left with on this side of the equation is n. On the right side, I'm adding 16 plus 15, which gives me 31. Now that I have my value of n equals 31, I'm going to substitute it back into my original equation, which just means I'm going to replace n with 31. So instead of n, I write 31, and then minus 15 equals 16. Well, 31 minus 15 is 16. 16 equals 16. That is a true statement, so I'm good to go. All right, now my last one here, this is a special case. I'm going to put a little star next to this one. This one is actually not a single-step algebra equation. This is actually a two-step algebra equation. I know it looks very, very similar to that of our first one, but there's something that we have to understand here. So first of all, if I look at my variable here, it's 15 minus n. Now you might be able to just look at this and answer this without doing the solving steps, but I want to show you because there's going to be times when you're not able to. So when I look, this 15 is actually a positive 15. This n is actually a negative n. If I were to solve this, there's a couple ways I can do it, but if I were to get rid of the 15, I would still have a negative n on the left side of the equation. So there are two different ways we can go about solving this, okay? The first way I'm going to show you is the same way we've been doing, which is let's start on the side with the variable. When I start on this side, I want to get rid of the 15. Now be careful. The negative sign here goes with the n. That is a negative n. The 15 is just a 15, which means it's a positive 15. So I'm going to have to subtract 15 in order to get rid of that positive 15 there. So that cancels out, and I have to do the same thing on both sides. 12 minus 15 gives me negative 3. Because if I have 12 and I'm taking away 15, it means I'm going 3 less than 0. And then I have, on this side now, I still have a negative n. Well, if negative n equals 3, right, it's really like saying the opposite of n is negative 3. Well, if the opposite of n is negative 3, then positive n would be positive 3. When we change the signs on one of our values from a negative to a positive, we have to do it to all the values in our equation. So I can change the value of n from a negative to a positive, and then I have to also do that to the negative 3 as well. Okay, but I did tell you there was one other way to solve this. So if I look at the original equation again, 15 minus n equals 12. I can immediately, one thing I could do is see that I have a negative n here, and I can just move this to the other side by adding n to both sides of my equation. So if I add n, negative n plus n is the same thing as saying n minus n, which is 0. So now I get 15 equals 12 plus n. And now I can do my normal inverse operations to solve this by subtracting 12, and I get that n equals 3. So we see it doesn't really matter which way we do it. We arrive at the same answer either way. This is a special case scenario when we have a value minus the variable. So this one is 15 minus n. When the n is negative, or the x or the y or the w, whatever the variable is negative, this is a special case in which we actually have to do an additional step in order to find our answer. All right, thank you for watching. Hopefully this was helpful. Make sure you're doing the try this on the back and enter your answers into Schoology. Have a great day, guys.